Graphical method of solution of a pair of linear equation. In the previous section, you have seen how we can graphically represent a pair of linear equations as two lines. You have also seen that the lines may intersect or may be parallel or may coincide. Can we solve them in each case? And if so, how? We shall try and answer this question from the geometrical point of view in this section. Let us look at the earlier example one by one. In the situation of example 1, find out how many ideas on the giant wheel Akla had and how many times she played Hopla. In figure 3.2, you notice that the equation representing the situation are geometrical shown by two lines intersecting at the point 4, 2. Therefore, the point 42 lies on the lines represented by both the equation x minus 2y is equal to 0 and 3x plus 4y is equal to 20, and this is the only common point. Let us verify algebraically that x is equal to 4 and y is equal to 2 is a solution of the given pair of equations. Substituting the value of x and y in each equation, we get 4 minus 2 into 2 is equal to 0 and 3 bracket 4 bracket close plus 4 bracket 2 bracket close is equal to 20. So we have verified that x is equal to 4, y is equal to 2 is a solution of both the equations. Since 4, 2 is the only common point on both the lines, there is one and only one solution for this pair of linear equations into variables. Thus, the number of rides Akla had on giant wheel is 4 and the number of times she played Hoppa is 2. In the situation of example 2, can you find the cost of each pencil and each eraser? In figure 3.3, the situation is geometrically shown by a pair of coincide lines. The solution of the equation are given by the common points. Are there any common points on these lines? From the graph, we observe that every point on the lines is a common solution to both the equations. So the equation 2x plus 3y is equal to 9 and 4x plus 6y is equal to 18 have infinitely many solutions. This should not surprise us because if we divide the equation 4x plus 6y is equal to 18 by 2, we get 2x plus 3y is equal to 9, which is the same as equation first. This is both the equations are equivalent. From the graph, we see that any point on the line gives us a possible cost of each pencil and eraser. For instance, each pencil and eraser can cost Rs3 and Rs1 respectively, or each pencil can cost Rs 3.75 and eraser can cost 0.50 and so on. In the situation of example 3, can the two rails cross each other? In figure 3.4, the situation is represented geometrical by two parallel lines. Since the lines do not intersect at all, the rail do not cross. This also means that the equation has no common solution. A pair of linear equation has no solution is called an inconsistent pair of linear equation. A pair of linear equation into variable which has a solution is called consistent pair of linear equation. A pair of linear equations which are equivalent has infinitely many distinct common solutions. Such a pair is called a dependent pair of linear equation into variable. Note that a dependent pair of linear equation is always consistent. We can now summarize the behavior of lines representing a pair of linear equation into variable and the existence of solution as follows. The lines may intersect in a single point. In this case, the pair of equation has a unique solution. Consistent pair of equation. Number second, the lines may be parallel. In the case the equation has no solution. Inconsistent pair of equation. The lines may be number third. The lines may be constant. In this case, the equation have infinitely many solutions, dependent, consistent pair of equations. Let us now go back to the pair of linear equations formed in example first, second, and third, and note down what kind of pair they are geometrically. First, x minus 2y is equal to 0 and 3x plus 4y minus 20 is equal to 0. The lines intersect. Second, 2x plus 3y minus 9 is equal to 0 and 4x plus 6y minus 18 is equal to 0. The lines coincide. Third, x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. The lines are parallel. Let us now write down and compare the value of a1 upon a2, b1 upon b2 and c1 upon c2. In all the three examples here, a1, b1, c1 and a2, b2, c2 denote the coefficient of equation given in general form of section 3.2. Serial number pair of plans a1 upon a2, b1 upon b2, c1 upon c2, and compare the ratio. Yeah, you can see it that in your screen also. Graphical representation, algebraic representation. So here two equation x minus 2y is equal to 0, 3x plus 4 minus 20 is equal to 0, and that's a1 upon a2 is equal to 1.3, and again it's minus 2.4, and it's compared to ratio it is not equal. That means it's intersecting lines and exactly one solution. And if the ratio is equal, then is constant lines and it has infinitely many solution. And if it has equal to a1 upon a2, b1 upon b2 but not equal to c1 upon c2, that means it's parallel line and no solution. From the table above, you can observe that if the lines represented by the equation ax plus b1 y plus c is equal to 0 and a2x plus b2 y plus c is equal to 0 are first intersecting, then a1 upon a2 does not equal to b1 upon b2. Second, constant, then a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Here all ratios are equal. And number 3, parallel, then a1 upon b2 is equal to b1 upon b2 but it is not equal to c1 upon c2. In fact, the converse is also true for any pair of lines. You can verify them by considering some more examples by yourself. Let us consider some more examples to illustrate it. And example number 4. Check whether the pair of equation x plus 3y is equal to 6 and 2x minus 3y is equal to 12 inconsistent is consistent. If so, solve them geometrically. Now we are going to another concept 3.4, algebraic method of solving a pair of linear equation. In the previous sections, we discussed how to solve a pair of linear equations graphically. The graphical method is not convenient in case where the point representing the solution of the linear equation has non-integral coordinate like under root 3 to under root 7, minus 1.75, 3.3, and 4 upon 13, 1 upon 19, etc. There is every possibility of making mistakes while reading such coordinate. Is there any alternative method of finding the solution? There are several algebraic methods which we shall now discuss. 3.1 3.4.1 Substitution method. We shall explain the method of substitution by taking some example. Example number 7. Solve the following pair of equation via substitution method. 7x minus 15y is equal to 2 first, and x plus 2y is equal to 3, second equation. Solution. We pick either one of the equation and write down one variable in term of other. Let us consider the equation x plus 2y is equal to 3 and we write it as x is equal to 3 minus 2y. Step number 13. Substitute the value of x in equation. First we get 7 and bracket 3 minus 2y bracket close minus 15y is equal to 2 is equal to 21 minus 14y minus 15y is equal to 2 and again is equal to minus 29y is equal to minus 19. Therefore, y is equal to 19 upon 29. Step number 3. Substituting this value of y in equation 3 we get x is equal to 3 minus 2 bracket 19 upon 29 bracket close is equal to 49 upon 29. Therefore, the solution is x is equal to 49 upon 29 and y is equal to 19 upon 29. Verification. Substituting x is equal to 49 upon 29 and y is equal to 19 upon 29, you can verify that both the equation first and second are satisfied. To understand the substitution method more clearly, let us consider it step by step first. Find the value of one variable, say y, in terms of other variables x from either equation, whichever is convenient. Step second. Substitute this value of x in the other equation and reduce it to an equation in one variable in terms of x which can be solved. Sometimes, as in example 9 and 10 below, you can get a statement with no variables. If the statement is true, you can conclude that the pair of linear equation has infinitely many solutions. If the statement is false, then the pair of linear equation is inconsistent. Step 3. Substitute the value of x or y obtained in step second in the equation used in step first to obtain the value of other variable. Remark. We have substitute the value of one variable by expressing it in form of the other variable to solve the pair of linear equations. That is why the method is known as substitution methods. And now example 8. Solve question 1 of exercise 3.1 by method of substitution. Solution. Let S and T be the age in year of Aftab and his daughter respectively. Then the pair of linear equation that represent the situation is s minus 7 is equal to 7 bracket t minus 7 bracket close is equal to s minus 7t plus 42 is equal to 0 and s plus 3 is equal to 3 bracket t plus 3 bracket close is equal to 7 minus 3 into t is equal to 6. That's second equation. Using equation second, we get s is equal to 3t plus 6. Putting this value of s in equation first, we get 3t plus 6 minus s 7t plus 42 is equal to 0 is equal to 40 is equal to 48, which gives t is equal to 12. Putting this value of t in equation second, we get s is equal to 3 and bracket 12 bracket close plus 6 is equal to 42. So Aftab and his daughter are 42 and 12-year-old respectively. Verify this answer by checking if it is satisfy the condition of the given problem. Cross multiplication method. So far, you have learned how to solve a pair of linear equations into variable y graphically. Substitution and elimination method. Here we introduce one more algebraic method to solve a pair of linear equations which for many reasons is a very useful method of solving these equations. Before we proceed further, let us consider the following situation. The cost of orange and 3 apple is Rs 35 and the cost of 2 orange and 4 apple is Rs 28. Let us find the cost of an orange and an apple. Let us denote the cost of an orange y r x and the cost of an apple y r y. Then the equation form are 5x plus 3y is equal to 35 is equal to 5x plus 3y minus 35 is equal to 0, and its first equation. 2x plus 4y is equal to 28 and is equal to 2x plus 4y minus 28 is equal to 0, its second equation. Let us use the elimination method to solve this equation. Multiply equation first by 4 and equation second by 3, we get 4 into 5 into x plus 4 into 3 into y plus 4 minus 35 is equal to 0, and 3 into 2x plus 4 into 4y plus 3 into minus 28 is equal to 0. That's fourth equation. Subtraction equation 4 from equation 3, we get 5 into 4 minus 3 into 2 bracket close into x plus bracket 4 into 3 minus 3 into 4 bracket close into y plus bracket 4 into minus 35 minus 3 into minus 28 bracket close is equal to 0. Therefore, x is equal to minus bracket 4 into minus 35 minus 3 uh, multiply minus 28 upon 5 into 4 minus 3 into 2, and is equal to x is equal to 3 into minus 28 minus 4 into minus 35 upon 5 into 4 minus 23, and it is now fifth equations. Equation first and second are written as x plus by plus c is equal to 0 and a2x plus b2y plus c2 is equal to 0. Then we have 8 1 is equal to 5, b1 is equal to b3, c1 is equal to minus 3, e5 35, a2 is equal to 2, b2 is equal to 4, c2 is equal to minus 28. Then equation 5 can be written as x is equal to b1 c2 minus b2 c1 upon a1 b2 minus a2 b1. Similarly, you can get y is equal to c1 a2 minus c2 a1 upon a1 b2 minus a2 b1. By simplifying equation 5, we get x is equal to minus 84 up plus 140 upon 20 minus 6 is equal to 4. Similarly, y is equal to minus 35 into 2 minus 5 into minus 28 upon 20 minus 6 is equal to minus 17 plus 140 upon 14, and it is equal to 5. Therefore, x is equal to 4, y is equal to 5 is the solution of the given pair of equation. Then the cost of an orange is 4 and the cost of an apple is 5. Now, summary of the chapter. You have studied the following points in this chapter. First, two linear equations in the same two variables are called a pair of linear equations in two variables. The most general form of a pair of linear equations is ax plus b1y plus c is equal to 0, a2x plus b2y plus c2 is equal to 0, where a1, a2, b1, b2, c1, c2 are real numbers such that a1 square plus b1 square is not equal to 0 and a2 square plus b2 square is not equal to 0. A pair of second point. A pair of linear equations into variable can be represented and solved by the graphical method as well as algebraic method. Third point. Graphical method. The graph of a pair of linear equations into variable is represented by two lines. First, if the lines intersect at a point, then the point gives the unique solution of two equations in the case the pair of equations is consistent. Second, if the lines are coincide, then there are infinitely many solutions, each point on the line being a solution. In this case, the pair of equations is dependent consistent. And third point of graphical method is if the lines are parallel, then pair of equation has no solution. In this case, the pair of equation is consistent. Now, algebraic method. We have discussed the following method for finding the solutions of a pair of linear equation, and it is substitution method, elimination method, and cross multiplication method. Fifth, if a pair of linear equation is given y, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then the following situation are arise. a1 upon a2 is not equal to b1 upon b1. In this case, the pair of linear equation is consistent. Second, a1 upon a2 is equal to b1 upon b2, it not equal to c1 upon c2. In this case, the pair of linear equation is inconsistent. Number third, a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. In this case, the pair of linear equation is dependent or consistent. Sixth point of summary. There are several situations which can be mathematically represented by two equations that are non-linear to start with, but we alter them so that they are reduced to a pair of linear equations. Thanks.